Bismillahirrahmanirrahim. What is a sequence and what is a series? Sequence, everybody knows about sequence. So what is a sequence? Sequence, when numbers are arranged according to some definite rule, we get a sequence. Here the definition is, for sequence, a list of numbers or objects in a special order. A list of numbers or objects in a special order. For example, 3, 5, 7, 9 is a sequence starting at 3 and increasing by 2 each time. Here we have a statement about sequence. What is a sequence? Sequence can be defined in two ways. The first way is the arrangement of numbers according to some definite rule. It is called a sequence. Another definition is, a sequence is a function whose domain will be the set of natural numbers or the set of positive integers and whose range will have the terms of the sequence. So these two definitions are used for a sequence. In this example, if we look to the term 3, 5, 7, 9, what is the rule used for this arrangement? If we add 2 with 3, we get 5. Similarly, if we add 2 with 5, we get 7. Similarly, we get 9. Here the rule used for the creation of this sequence is by adding 2 with every term, we get the next term. So it is something about sequence. Now we come to the series. When you add the values in a sequence together, that sum is called a series. We have both finite and infinite series. Example, this is a sequence whose terms have been separated by comma. Now here we see the terms of the sequence in summation form. So it is a series. This one is a sequence, this one is a series. What is finite sequence and infinite sequence? If the finite sequence is that sequence where the first term and last term is known, that sequence is called finite sequence. And when the first term is known and the last term is unknown, but the terms goes up to infinity, that sequence is called infinite sequence. If we add the terms of a finite sequence, we get finite series. Similarly, if we add the terms of infinite sequence, we get infinite series. Now look, here we have finite and infinite sequence. Finite sequence, what is finite sequence? If the first term is denoted by a1 and if that term is equal to a, similarly second term is a2, third is a3, last term is an, then here we see the first term and the last term. So it is a finite sequence. Look to this sequence, it is finite because we see first term a1, last term, this is first term, this is last term, so it is finite sequence. Now if we look to the other sequence, this sequence is such that first term a1 is known, last term is unknown. This an is not the last term, but it is the inner term, and the term goes up to infinity. So this is an example of infinite sequence. Here we see finite sequence, here we see infinite sequence. If we add these terms, if we write these terms in the summation form, we will get finite series, and if we write them in summation form, we get infinite series. Now we come to the third slide. We read about sequence, finite sequence, infinite sequence, finite series, infinite series. Now here we see arithmetic progression. Arithmetic progression and arithmetic sequence both represent the same name. or in short form it is denoted by AP. What is arithmetic sequence? A sequence is arithmetic if the difference between consecutive term is constant. What is consecutive? By consecutive we mean for the A1 the next term will be A2, so A1 A2 are consecutive to A2, the next term will be A3. These terms are consecutive, these terms, all these are consecutive. If we find the difference of any two consecutive, here we see this is a, these two are consecutive, which is equal to D. Similarly, these two are consecutive whose difference is this. These are consecutive whose difference is this. Whenever a sequence is such that the difference between two consecutive terms is the same, then such a sequence is called arithmetic sequence. The sequence A1, A2, A3, A4, this sequence is called arithmetic sequence. Why? Because the difference of their consecutive term is the same. Arithmetic sequence. Now here we see again arithmetic sequence. What will be the standard form of arithmetic sequence? An arithmetic sequence is of the form A plus D, A plus 2D, A plus 3D. This is the standard form of arithmetic sequence. This A is the first term, A plus D is the second, A plus 2D is the third, and this one is the fourth term. For fourth term we put 3 with D. For third term we put 2 with D. So what this term stand for? Here we see 19, so this will give us a 20th term. 20th term of arithmetic sequence will always be equal to A plus 19D. What is this term? Here we see n minus 1, A plus n minus 1 to do. So this gives us, this will give us the n term. That n term is denoted by Tn or An. So this is the formula to find the n term or general term of any arithmetic sequence. So here we see the standard form of arithmetic sequence, the 20th term of that arithmetic sequence, the n term of that arithmetic sequence. Remember, D represents common difference. This common difference will always be the difference between two consecutive terms. Generally, it will be equal to An minus 1. This is An, this is An minus 1. If here is 2, here will be 1. If here is 3, here will be 2. So this represents the difference between two consecutive terms. And this one, this is the formula to find the inner term of arithmetic sequence. So remember these two. To find the common difference, we will use the above formula. To find the inner term or general term, we will use the below formula. Here we see again sequence. We read about sequence. Now these two sentences will again describe about sequence. There are two types of sequences: arithmetic, geometric. We have another sequence, harmonic sequence. So what is arithmetic? For arithmetic sequence, we add a common difference each time. In arithmetic sequence, we add a common difference each time. Here we see geometric. This is geometric sequence. In geometric sequence, what we do, we multiply common ratio each time. In geometric sequence, we multiply every term by a constant number. In arithmetic sequence, we add every term by a constant number. which is called common. We use for multiplication is called common ratio, while in the sense of arithmetic, that number which we add with the term is common difference, denoted by D. So this was a little bit further explanation. Now again, look, here we see an, which is equal to a1 plus n minus 1 into d. If we look to this expression equality, this a1, what is this a1? This a1 is the first number in the sequence. What is this n? This n is the number of the term you are looking for. N means the number of terms in the given sequence. What is this d? This d represents the common difference, that number which we use, which we add with a term to get the next one. What is this an? This an is this an represents the inner term of the sequence. So we have to remember this formula, where a1 stand for first term, an stand for inner term, d stand for common difference, n stand for the number of terms. Now look to this sequence. Here we have to find the 7th term. Find the 7th term of the sequence 2, 5, 8. Determine the pattern. Determine the pattern. Add 3, known as the common difference. Write the new sequence. If we look to the arrangement of numbers, we will see that if we add 3 with 2, we get 5. Similarly, if we add 3 with 5, we get 8. And in this way, if we continue adding 3 with every term, we will get the next one. So the 20th term of the 7th term of the sequence. Here we have to find the 7th term, and 7th term here is 20. So this is the 7th term is 20. So here for the sequence 2, 5, 8 and so on, we just find out the pattern, and we reach to the 7th term, which is equal to 20. Arithmetic sequence, a little bit further explanation or revision of the definition. An arithmetic sequence is a sequence in which each term after the first is obtained by adding the same text number called the common difference to the preceding term. Arithmetic sequence. Now look at the statement, and this one and this one. Arithmetic sequence. When you want to find a large sequence, this process is long and there is great room for error. In the previous slide, we found out the 7th term, which was 20, by looking to the pattern. Sometimes we have been asked to find out the 20th term, the 100th term. Then by ordinary method, it will take a lot of time. So what will be the easiest way to find out any desired term? For that, to find out the desired term, we will use this last formula, a n is equal to a1 plus n minus 1 into d. Look, a sequence is arithmetic if each term minus the previous term is equal to d. Each term means if we put here a2, then previous term will be a1, and this difference will be equal to d. If we put each term here a4, then the previous term from a4 will be a3. The previous term will be a3. So a4 minus a3 will be equal to d, where d is a constant. For the sequence, for the below sequence, this sequence, d second term minus first term. Second term is 4, first term is 2. 4 minus 2 will be equal to 2. Similarly, third term minus second term. Third term minus second term, they are talking about this. Third term minus second term will be equal to 2. So here how we will find the common difference. To find out the common difference, we will use this one, each term minus the previous term, and it will be equal to d. One, two, three, four, 5. What type of sequence is this? If we look, if we add 1 with 1, we get 2. Similarly, if we add 1 with 2, we get 3. So here d is equal to 1. It is an arithmetic sequence. If we look to the second sequence, if we add 5 with 0, we get 5. If we add 5 with 5, we get 10. Similarly, adding 5 again, we get 15. So it is an AP. The second one is AP with common difference d is equal to 5. In the last sequence, if we add minus 3 with the first term 5, we get second term. Looking to this sequence, if we add minus 3, we get 2. If we add minus 3, we get minus 1. So this is an example of arithmetic sequence with common difference d is equal to minus 3. So in brief, if we look to this sequence, d will be equal to 1. Similarly, if we and this is the explanation, read this explanation and it's easy. So this is the this is the second, this was the second sequence. Here is the explanation. If we add 5 with 0, we get 5. If we add 5 with here, we get next. So this is an example of arithmetic sequence. These are further example of arithmetic sequence, and the common difference have been shown below every sequence. 3 is the common difference for first sequence, 4 is the common difference for second, and similarly minus 3 is the common difference for the last sequence. Here, now look to this one. Look to this question. Find the 15th term of the sequence. The given sequence is 34, 30, 12, and we have to find the 15th term. To find out any term, we will always use this formula. We will use this formula. If we look to the sequence, this is the first term 34 d. 23 minus 34 is equal to minus 11. Number of terms. Number of terms हम किस तरह मालूम करेंगे? नंबर ऑफ टर्म यहाँ से हमें पता चलेगा. यहाँ वो हमसे पूछ रहे हैं कि 15 टर्म, तो वो उसी 15 से हमें पता चल जाए कि n मसाई है 15. अब ये फार्मूला है, यहाँ पे पुटिंग हो गया है मुख्तलिफ वैल्यूज़ का, और ये हमारे साथ आंसर आता है. अब इसको देखिए, यहाँ पे हमारे साथ complete the arithmetic 1, 4, 7 up to 8 terms. वो कह रहे हैं कि 8वें टर्म तक इस सीक्वेंस को मुकम्मल करें. तो सबसे पहले हमें ये मालूम करना है कि व्हाट इज़ कॉमन डिफरेंस. अगर हम इन दोनों का डिफरेंस मालूम करें, ये डिफरेंस है, तो ये हमें डी देगा, ये डी देगा. तो हमारे साथ डी भी मौजूद है, हमारे साथ 1 ये फर्स्ट टर्म है, और नंबर टर्म जो है वो 8 है. तो इस तरह हम इसी क्वेश्चन को इस तरह मालूम कर सकते हैं. ये जो फार्मूला है, ये फर्स्ट टर्म है, ये सेकंड है, ये थर्ड है, और हमारे साथ 8. तो अगर हम 4 दर्ज करें तो 10 आएगा. अगर हम 5 दर्ज करें तो 13. इसी तरह 6, 7, 8. इस तरह अगर हम पुटिंग करते जाए तो ये हमारे साथ नीचे वाला जो सीक्वेंस है वो हमारे साथ कंप्लीट हो जाएगा. सीक्वेंस एंड सीरीज़. अब यहाँ पे दोबारा हम आते हैं सीरीज़ की तरफ. समेशन नोटेशन। तो हमने पढ़ा था कि व्हाट इज़ अ सीरीज़, इफ़ वी राइट द टर्म्स ऑफ अ सीक्वेंस इन द समेशन फॉर्म वी कॉल इट अ सीरीज़. So this one represent a series in the sigma notation. The sum of the first n terms of a sequence is written as a1, a2 up to an. This summation of the inner term for the given sequence can be represented in sigma notation as sigma ak, where k is equal to 1 up to n. यहाँ k की जगह हम कोई भी लफ्ज़ लिख सकते हैं, ए आई ए जे ए के, इसको हम डमी वेरिएबल कहते हैं. इसकी वजह हम यहाँ करते हैं कि ये स्टार्ट होगा एक से और ये जाएगा n तक. ये जो है इस यहाँ हम लिख सकते हैं k इज इक्वल टू n, k इज इक्वल टू 1 अप टू k इज इक्वल टू n. तो इसी फाइनाइट सीरीज़ के लिए सिग्मा नोटेशन यही है. स्टार्टिंग टर्म k इज इक्वल टू 1 से हमें मिलेगा और k इज इक्वल टू n से हमें लास्ट टर्म मिलेगा, और ये हमें फाइनाइट सीरीज़ दिखाता है. इसी तरह अगर हमारे साथ फर्स्ट टर्म नोन हो और लास्ट टर्म अननोन हो और इसी इनफाइनाइट सीरीज़ को हमने सिग्मा नोटेशन में लिखना है तो हम इस तरह लिखेंगे. सिर्फ यहाँ पे इन्फिनिटी लिखेंगे. यहाँ इसका मतलब है कि k इज इक्वल टू 1 हमें फर्स्ट टर्म देगा और इस तरह k इज इक्वल टू 2 हमें सेकंड टर्म देगा और k इज इक्वल टू इन्फिनिटी हमें वो टर्म देगा जो आखिर में कहीं मौजूद होगा. Arithmetic series. The sum of the terms in a sequence are called a series. There are two methods used to find arithmetic series, formula and sigma notation. वो तो हमने पढ़ा. अब यहाँ पे देख ले ये एक डिराइवेशन है. अब अगर हम यहाँ देखें सम ऑफ द ये देख ले ये वाला, इसको अगर हम देख ले तो नीचे वाला हमें स्टैंडर्ड फॉर्म ऑफ ई पी है a1 प्लस डी a1 प्लस 2d. उस तरह ये हमारे साथ स्टैंडर्ड फॉर्म में ए पी है. एस एन का मतलब है सम ऑफ फर्स्ट एन टर्म्स ऑफ द सीक्वेंस. तो ये एन तक समेशन ऑफ टर्म्स है. अगर इसकी जगह हम ये वैल्यूज़ पुट करें और इसको इस तरह a1 सारे रीअरेंज करें, डी वाले यहाँ पे पुट करें. अभी इसको देखिए a1 कितनी a1 है, ये यहाँ हमें n a1 दिखाई देते हैं. यहाँ अगर हम इसको चेक करें, d कॉमन निकाले, बाकी वो 1 से लेकर n-1 तक हम यहाँ रखें, ये अपनी जगह पे आ गया, d अपनी जगह पे आ गया. और ये जो है ये हमारे साथ एक नॉन रिज़ल्ट है. ये हम इस तरह लिख सकते हैं, अगर n की जगह n-1 हो तो इस तरह. तो ये वैल्यू यहाँ पे जब हम पुट करेंगे और थोड़ा सिंप्लीफाई करेंगे तो हम यहाँ पे आते हैं. ये हमारे साथ फार्मूला है एस एन इज इक्वल टू n/2 2a1 प्लस n-2d. एक तो ये याद रखना है. अब अगर इसको हम कुछ रीअरेंज करें, 2a1 से a1 यहाँ पे रख लिया और बाकी यहाँ पे, तो ये a1 अपनी जगह पे और ये हमारे साथ an है. तो ये भी फार्मूला रिमेंबर होना चाहिए. अब ये नीचे वाले देखिए 9 7 5 3 1 a20 और s20 मालूम करना है. तो सबसे पहले हम n फार्मूला पर n टर्म लिखेंगे, फिर यहाँ पुटिंग करेंगे और d मालूम करेंगे. तो ये हमारे साथ 28 टर्म आ गया. और ये जो फार्मूला है हमने यहाँ पे लिखा, a1 हमें मालूम है, n हमें मालूम है. n का मतलब क्या है? n का मतलब है n इज इक्वल टू 20. तो ये सारे वैल्यू यहाँ पुट करने के बाद हम 20 टर्म्स का समेशन यहाँ मिलेगा. ये वही फार्मूला है जो हमने पिछली स्लाइड में पढ़ा. तो उसके दो फॉर्म थे. ये आखिर वाला फॉर्म है. जब कभी हमें अरिथमेटिक सीरीज़ का समेशन मालूम करना है तो हम ये फार्मूला इस्तेमाल कर सकते हैं. एस एन इज इक्वल टू n/2 a1 प्लस an. मतलब ये है कि एस एन इज इक्वल टू n/2 a1 फर्स्ट टर्म प्लस n टर्म. a1 मीन्स फर्स्ट टर्म, n मीन्स नंबर ऑफ टर्म्स, an वैल्यू ऑफ द टर्म. अरिथमेटिक सीरीज़. अब अगर हम यहाँ पे देख ले, ये हमारे साथ एक क्वेश्चन है. वो हमसे वो क्या मांग रहे हैं? फाइंड द सम ऑफ द फर्स्ट पार्टी टर्म. सम ऑफ द फर्स्ट पार्टी टर्म, इसका मतलब कि n इज इक्वल टू 40 हो गया. ये सबसे पहले पार्टी टर्म, इसका मतलब कि n इज इक्वल टू 40 in arithmetic series in which t1 is equal to 70. t1 means a1 is equal to 70. डी इज इक्वल टू -21, ये तो ऑलरेडी हमें मालूम है। तो n इज इक्वल टू 40 मालूम है, फर्स्ट टर्म 70 मालूम है, n टर्म मालूम करना है और Sn मालूम करना है। तो ये हमारे साथ n टर्म मालूम करने के लिए फार्मूला है। A1 हमारे साथ मौजूद था, D भी हमारे साथ मौजूद था। तो अगर ये -21 इसी ब्रैकेट को हम ले आए और 70 के साथ सिंप्लीफाई करें तो ये हमारे साथ आता है। अब ये n क्या है, ये n हमारे साथ 40 है, यहाँ ये 40 लिखा है, तो यहाँ 40 लिखे तो ये हमारे साथ आंसर आएगा। इस तरह एस एन इज इक्वल टू n/2 a1 प्लस an में अगर हम पुटिंग करें तो ये हमारे साथ 40 टर्म्स का समेशन आएगा। सो द सम ऑफ द फर्स्ट 40 टर्म इज दिस वन। अब इसी को देके ये एक खूबसूरत सा क्वेश्चन है। अब इसी को देके वो कह रहे हैं कि फाइंड अ फार्मूला फॉर द पार्शियल सम ऑफ दिस सीरीज़। यहाँ पे हमारे साथ फर्स्ट टर्म 1 है, सेकंड टर्म 3 है, थर्ड टर्म 5 है और ये 2n-1 लास्ट टर्म है। अगर हम फार्मूला इस्तेमाल करें Sn इज इक्वल टू n/2 a1 प्लस an, ये फार्मूला हम उस वक्त इस्तेमाल करेंगे जब हमें फर्स्ट टर्म मालूम हो। अगर जब कि भी हमें फर्स्ट टर्म मालूम हो और हमें लास्ट टर्म मालूम हो तो ये फार्मूला इस्तेमाल करना बहुत आसानी हमें देता है। ये हमारे साथ फर्स्ट टर्म है, ये लास्ट है और ये n का मतलब है नंबर ऑफ टर्म्स। तो whenever if we know about first term and the last term, we will use this formula, and by simplification we will get the sum of inner term is equal to